Dream to become the next Sir Isaac Newton or Albert Einstein?
Learn physics from Professor Suborno Isaac Bari. Let's start today's remote learning with Do Now.
Hello, Professor.
So, today we're going to be looking at the center of mass. Now, I'm not going to include any do not learn it because I'm going to give you a lesson. The team taught it first, but over time, you will master it. So, first, let's say we have a human body. And today we're going to make a problem typically focused on the leg. So let's say that we have a guy 1.7 years tall, but we're going to call him 100 units tall. Now, let's say the height from his hip to the tip of his foot is 52.1 units. The same units we use to measure his height. Whoa. Okay. So now let's zoom in. This is one of his legs. And this is going to be the ground. So let's say we're now like at a side view. We're like looking from a different angle. So now, let's say that this is exactly where his hip ends. So there's really three sections: your hip, your ankle, and your foot. So each of them has their own center of mass. I'd say the foot one is somewhere around here. But for the whole foot, there's really one average center of mass, somewhere around the hip and the ankle. What we want to do is find the height of that center of mass relative to the ground. Well, so what we're given is we know the hip height, and then we also say that from the hip to the ankle, it's going to be 33.9 units, I guess. And then from the hip to we know the hip height. And then the length of the hip itself is just 9.6 units.
And also to the last center of mass, Professor?
Oh, we know.
50.3,
let's say.
yeah, 50.3, I think. I'm just guessing, I measured myself.
And then we're going to finally resume the hip height because...
Is it 51.2 or 52.1?
Oh, 52.1.
Let's not get messed up. Professor, you put a box. That looks weird. Can you erase it?
Okay, so...
Just write it as... I like the way you wrote that one.
Units. Okay. Now, we're going to... Now, this is pretty easy. We know that this is M1. No. The mass of... one and the position 1. Oh, wait. I want to mention the mass percentiles. So let's say the hip is very dense, 21.5% of mass. The ankle comprises of 9.6, much more loose.
And the feet are 3.4%?
Okay, 3%. Okay. So I want x1 plus n2 x2 plus n3 x3 divided by what should it be? The sigma
the total
mi,
mass.
Sigma mi, sum of 1 to 3 because we have 3.
Remember, we did something like that in linear algebra.
Okay.
Alright.
So start. Now, we're going to plug in, and that should be almost the last step. So M1 we know is 21.5. X1 is going to be 9.6.
9.6. Professor, can you write big? I don't think anyone can see from that distance.
21.5 times 9.6 units plus
Please write bigger, Professor.
9.6. This is the biggest I can write when allowed this amount of space.
Okay.
And yes, everybody can see that. I just like to zoom ourselves in a little bit.
Okay.
Okay, that
Okay.
should be good.
Okay. Please keep going.
Now,
Yeah, I like that voice. Please keep.
plus M3X3 is going to 3.4 times 52.1 because that's the hip height. We don't really need the 52. So now M1 is so 21.5 plus 9.6 plus 3.4. Okay.
Yeah, Professor, yeah.
So somebody, can somebody please do the calculation?
Yeah, I got 20.7. I got 20.7. Is that right?
Wrong.
20.4.
Okay.
Thank you, Professor.
20.4.
Please write bigger.
I can't write bigger. This is all that my space allows me to write.
So what does 20.4 represent?
20.4 represents the height of the central mass relative, the height of the central mass relative to the hip.
So can you draw it in for us, Professor?
So let's say, let's make it.
You might want to use the green color, right?
No. Green is the
Okay,
front.
sorry, yeah.
So
Because I don't think the lid is visible. Use blue, I think there is blue. Thank you.
now we're going to. We know that this is 20.4, and we are multiplying this. Now we know 52.1 minus 20.4 because the whole hip height is 52.1, and then 20.4 is the height of the center of mass relative to the hip height. Well, from here to here is 20.4. Yes, you can understand what I mean. It's not really even, not to scale.
Yeah, I get it. Thank you, Professor.
So 52.1 minus 20.4. Somebody do that.
30.8? Yeah, I got 30.8, Professor.
Okay. So now we have.
Sorry, 31.8, I think. Yeah.
Yeah, 31.8.
Wow.
But
I
that's
guess I'm
not.
a genius.
But whoa.
It's okay.
Okay. But that's just in units.
Can you represent it on the diagram?
Yeah. 31.8.
So how do we find the actual?
So we can use proportion. So we know that 100.
Can you go all the way to the left, Professor? I can't see.
There's nothing. Oh. This. Okay. So 1.7 meter over something, the meter we want to find,
Okay, sure.
equals to 100 over we want.
Can you write a little bit bigger? I don't think the people can see from the back.
1.7.
Wait. Why did you put 31.8?
Oh, remember the height.
Oh, I
the
see.
center mass
Okay,
relative to
thank
the
you.
gram in units.
Why don't we just solve for x?
Yeah, that's what we're going to try to do,
Okay.
right?
So do you want me to plug that in?
So wait, 100. Yeah, 1.7 times 31.8.
So 1.7 times 31.8.
31.8.
Oh, I got a 0.54.
Oh,
0.5406. 0.5406.
You don't have to be that precise, but 0.54. Wait,
Can you write it big, Professor? I can't really see anything.
wait. Everybody can see, even the guys in the back.
Thank you,
Even
Professor.
that creepy Joe in the back. Why are you saying you can't see?
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.